Okay, here's our video on exponential growth and decay. So when we say something is growing exponentially, so we can make a little rough chart here, we're saying it's increasing exponentially, pretty rapidly. That's what exponential growth means. So let's say, for example, that you wanted, let's say you put in $50, you invested $50, and the rate was, let's say, 6%. So if you want to find out how much you have, right, you got to do 50 times 0.06. So 50 times 0.06 is $3. So at 6%, the interest would be $3. You made $3. But you started with 50, so $53 would be your new value. $53. Put that there. So what we can do is we can put a 1 with the percent, and we can get our true value. So let me do that again. So this is the value. Let's say we started with 50, right? And it's at 6%, which we know 6% is 0.06. So what we can do is we're going to take the original value, which is 50, and we're going to multiply it by 1 plus the interest rate. And if we do that, we're going to get the 53. So with growth, always add a 1 to it. The 1 represents the original amount. And the way it is, this is how it would look in the formula. 1 plus R. R is the rate. So again, we're just doing growth right now. So let's say you have this, and this is the equation for growth. You're going to say Y, A is going to be the amount, or our original amount. From the previous example, it was 50. 1 plus R, and then we have this exponent up here. So one thing you should know about exponential growth equations is they'll have an exponent up there. So that's the equation. Let's do a model problem. Let's say a city has, let's say, 4,000 people. Right? That'll be A. And let's say it's projected to grow at a rate of 15% a year. So it'll be 1 plus 0.15. Okay, let's say, well, this will be the amount. And X is going to be time. So we can put a T there. Time. Or you can put an X. So let's try to figure this out. Is if this is growing at this rate, what will happen when T, or the time, is 5 years? What would be the projected population in 5 years? See if you can do that. Where would we put the 5? With the T. And by the way, year 0 is the initial start. Year 0. So anything to the 0 power is 1, so it would be 4,000 times 1. But in 5 years, you put the 5 there. So if you did that so far, let's just bring it up here. We're going to say this, if we did all this to the 5th power, this would be about 2.01 and so on. You can keep that in the calculator. And you would just times that by 4,000. So the projected growth of the city in 5 years should be about that. That's just roughly. On your calculator, you would have had decimals of 0.42875 and so on. So let's do another one. So let's say that the value of this rare stamp, whatever, say a stamp, let's say that right now the value is $15. And let's say it's projected to increase by, let's say, 30% every year. That's just a projection. What would be the cost of that stamp in 30 years? Well, let's just say 8 years. What would be the cost of that stamp in 8 years? So what do? Y equals, well, A again is 15. 30 years, so we have to put a 1 because it's growth plus 0.3. And not 30 years, 30%. And 8 is what it's projected to be in 8 years. So try that. So over here, we're going to have 15, and we're going to times it by 8.15. Put another number there. It's actually more numbers, but we can do that. And the stamp is projected. We'll put it over here to cost about $122.36, roughly. Now the other part is decay, when things decay. Decay rate. Or when things decrease. And sometimes you see this a lot with cars. When you take a car, when you buy a car, and the car's value will decrease over time. So with growth, we just put a plus sign. So with decay, we just put a minus sign. So let's say that this car, we bought a car, and it was, let's say it was $12,000. And it's projected to decrease in value 6%. So what do you think? How would you write this exponential equation? Okay, so y is going to equal 12,000. That's the original amount. It's going to be 1 minus 0.06, right? 1 minus 0.06. So let's say let's put a value to it. Let's put a year to this. I mean, let's say in 12 years, how much should the car be worth? Try that. So let's put it over here. It should be 12,000, right? And this will be 0.94 to the 12th power. And that will give us about 0.47. Let's just say 0.48 times it by 12,000. And that'll give us the car. So in 12 years, you bought the car for $12,000, and it's depreciating, it's decaying. Well, it's not decaying, it's depreciating. It's depreciating, and after 12 years, the car should be worth about $5,711. Let's say that you're at a game, and let's say they started with 350 people, right? And then every round, let's say 80% are eliminated. So this is a decay rate. It's not decaying, it's decreasing. So how would you write an exponential equation for this? Not for growth now, but for decreasing. Okay, so remember we have y, the initial value is 350, and what do we put in here? We're going to put 1 minus 0.8, right? Plus for growth, minus for decay or decreased values. Each round, so we can put an R or an X. At round 0, when the game began, it started with 350, right? Anything to the 0 power is 1. But what would happen at round, let's say round 8? Let's use 8 again. Well, if you did that, if you went to round 8, you would notice that you're getting zeros, right? There'll be no players left by round 8. 0.000896, which means just basically 0. So 8 rounds is too much based on this. So let's just say now, let's say 3 round 3. What happens at round 3? So if you did this at round 3, there should be 2.8 people left, basically, and we really can't have 2.8 of any people, right? So we could just say about 3 people are left after round 3. So any game that has an 80% elimination rate must be a hard game. Let's try one more. We have a hamster population. Let's say that this hamster population or rabbit population, it's 35,000. It's a lot of rabbits. And it's decreasing. It's decreasing. Right? And let's say it's decreasing at a rate of, let's say, 25%. Okay, we have y equals 35,000. 1 minus 0.25. And let's say we want to know, put t for years, what would the population be when t equals, let's say, 7? Try that. So you're going to have 35,000, right? And that'll be about 0.133, roughly. It's decreasing at that rate. In 7 years, you should have 4,000. Let's write it up here. Let's get another pen. Okay, so if we did this, then we'll put it over here. The rate, the rabbits or the hamsters or whatever they were, that should be the population, roughly, in 7 years. So that was exponential rate and decay and growth. We'll also talk about this number, this letter actually, E. That'll come up. We'll talk about that soon. And that E is just a natural number. It's a natural constant that we'll talk about. It's roughly related to 2.718, and we'll use it for other decay problems later on. Okay, great job.